I'm Dan Douthart, back with Gwinnett Woodworkers. We're shooting videos here in Rob's shop oriented toward the YouTube audience. We normally have our videos on Saturday morning groups in front of a live audience. And the cam work is always not conducive necessarily for YouTube videos because we're more oriented toward the live audience. So what we're trying to do now in Rob's shop is do a section or a group of videos that are oriented strictly for YouTube. We just did one video and I was using some particular tools, and we had some new turners in the group, and they thought it would be a good point to go through and explain the different types of tools. You know, I've been wood turning for about 4 years, not nearly as long as what a lot of people you see have been doing for 20 and 30, 40 years. So I've been doing about 4 years. I watched a lot of videos. I belong to several different wood turning clubs, saw local demonstrations. So I may have advanced a bit quicker than somebody that's a bit isolated and doesn't have that connectivity with local turning groups. So what we're going to do in this segment is I'm just going to go through and explain some of the different tools that I'm using and what the purpose are and what the difference is. So when I say I'm using a tool, you'll know what it is. So there's basically two different types of tools. There's scraping tools and cutting tools. Scraping tools, or as it says, they're not bevel rubbing. You just hold it on the tool rest and it scrapes the wood off. And it will remove wood, but it doesn't necessarily give you the best finish. You know, a scraper, this is a fairly large scraper. It's got about an 80-degree angle on the bevel. Even though you don't ride the bevel, you're going to have it in where the tool rest is basically going to be down in the center of rotation, and you're going to be cutting with the tool handle elevated and the cutting edge trailing. So if it does catch, it'll flip into clean air. Where if it's up here and it catches, it would try to dig in farther. So this is a scraper, a round nose scraper. Another common scraping tool is the tool that's being pushed for a lot of beginning turners is easy wood tools. Well, there are also scrapers. This has a carbide tip on it, and again, there isn't any bevel there at all to rub. But again, you hold this one is Easy Wood recommends holding this one with this level. They often actually have a level you put here on the shank and hold it level at the center rotation, and you just go back and forth and scrape the wood off. So it'll remove the wood, but it doesn't give you a real clean cut. You're going to have to do a lot of sanding with that. Now we'll get into cutting tools. The original old cutting tool, probably one of the first cutting tools that they had on a lathe, was the skew. A lot of people are afraid of the skew because it is easy to catch, but it just takes practice, and I recommend doing practice on it. So I've got 3 different skews here. This is about a 1 inch skew. It's not a real high quality skew, but it works for me. It's about a 1/4 inch thick, and I've got a radiused edge on it. The typical grind that you find on a skew, this is a 1/2 inch skew, and it's got the skew angle is straight, and that's the original conventional skew. The angle here, the thickness of the tool steel, you make the bevel about 1.5 times that thickness, and that should give you the proper combined angle on the skew. So this is a conventional you see a lot of people using this type of skew. Richard Raffin and Alan Lacer popularized a skew that has sort of a radiused edge on it. And they feel that this gives you a little more flexibility. So there's things you can do with this skew that you can't do with the other skew, and vice versa. But this one has the radiused edge on, instead of just a straight cut across there, it's radiused. And what you can do with this, you see Alan Lacer doing a planing cut, and he'll just be able to quickly, rubbing the bevel, just go in like that and just quickly remove material. And you can also use it as a standard skew, either point up or point down, but those are skews. And these are the tools that give you the highest, smoothest quality finish. They are cutting tools. You typically present the cutting edge at about a 45-degree shear angle, and it gives you a very clean cut. Then we have then you have gouges. There's spindle gouges and roughing gouges. The basic difference between a spindle gouge and a bowl gouge is the depth of the flute. This one is a spindle gouge. It's a much shallower flute. This is a bowl gouge with a deeper flute. I'll show you some different flute. And when I'm talking about the flute, it's the cutout area on the top of the gouge that recessed area is called the flute. So here I have 3 spindle gouges. Actually, I don't need to show you because those two are the same. This is a 1/2-inch steel, and this is a 3/8-inch steel. And the bevel angle, there's things called bevel angle. That's the angle of the cutting edge here on the nose of the tool, and then where the side of the flute is ground back, this part is called the wing. And this has got a swept back wing, so I can use it like a regular spindle gouge. I can also use it sort of like a skew, doing a planing type of cut on the edge. So it just makes it a little more versatile. So that's about a 45-degree angle on the nose of that. And then here's some that's got a more acute angle. What that allows you to do when you're making V cuts, it gives you the clearance angle is the angle between the top edge of the flute and the bottom edge of the bevel. So that's the clearance angle. It allows you to get into a finer, sharper detail. This is more a common spindle gouge. This one has a much shallower flute. The one on the one here on your left has a much shallower flute, and that's commonly referred to as a detail gouge. It has a little bit more steel. The cross section of it, being the flute being cut down and far, and the cross section of that, you can see that way it's only about less than 1/4 of an inch. Where on the detail gouge you've got a lot more steel, where the cross section is much heavier and will not give you quite as much chatter because it's got more steel behind it. So that's a detail gouge. And then for a little bit finer work, this is with the same kind of grind as those last two that I showed you, another spindle gouge. This is made out of 1/4-inch steel. So it's just for much finer work, and you can get into a little bit tighter places with that. Okay, and here's another type of spindle gouge. This is called a spindle roughing gouge. And the name says, it's for initially getting the rough. You got a piece of stalk that's square or bark on the outside, and it's just the roughing gouge to get it to the round state. And it typically is ground with about a 45-degree angle. And the wings are not swept back at all. It's just straight across. The nose is square, straight up and down, and with the wings not being swept back at all. And you can use that in a planing fashion like this. You can use it in a peeling cut like that. You can use it like that to get into a square corner. So you can use it at different angles. You can use it like this. Just any way you can present that cutting edge and give you about a 45-degree shear will give you the best cut. However, again, you can use it in a planing fashion or even a scraping fashion. You're not going to get as clean a cut. Then we'll go to the bowl gouges. Bowl gouges, again, have a deeper flute. And there's typically three This is a U-shaped flute. When you see the shape of the flute is pretty much just a U shape. And this is more of a conventional grind where you see the wings are not swept back very far on this one. And that has uses, and some you can do some things with this you can't do with the other one's got the swept back wings. But that's a U-shaped bowl gouge, U-shaped flute bowl gouge. And then we go to a V shape. You can see the wings on this one, where the other one had a big flute, U-shaped flute in the bottom. This is more of a V shape, where the side walls of the flute is straight, it's not curved, and it comes to a very sharp point, or a fairly sharp point. The wings are swept back on this one slightly, not as much as the next one I'll show you, but it's got swept back wings. And then this is a parabolic flute. See, the flute is, the walls, the wings here are curved and gives you sort of a parabolic shape going down to the bottom of the flute. This is the flute style that David Ellsworth uses on his bowl gouge with the swept back wings, severely swept back. And you can do a lot of things with this that you can't do with the other ones that I showed you. So the different grinds will allow you to do different things. The nose angle on this is about 60 degrees. So the spindle gouge, the nose, the bevel on the nose is 45 degrees or more acute, down to about 30, even 20, 25 degrees. Where on a bowl gouge, the nose angle, the bevel on the nose is going to be somewhere around in the 60 degree range, and that's what David Ellsworth has on his 60 degree. The V-shaped flute. Stuart Batty is a turner from England, and he has a grind, he calls it a 40-40 grind. And this is similar, I don't think it's quite the same, but on Stuart Batty's you have a 45 degree angle on the nose, from the inside of the flute out to the wing is a 45, and the swept back across the top is 45, or 40 degrees. 40 degrees here, 40 degrees on the side, 40 degrees here. So it gives you a clearance angle here of about 80 degrees. And he uses his bowl gouge like that for strictly doing bevel riding push cuts. Just another application, but that's one of the applications that's used with a V-shaped flute like that. With the David Ellsworth, you're using it, the way you use the David Ellsworth gouge is cuts where you're coming in sort of like this, and that V-shaped flute clogs up very quickly, and once the flute clogs up, it stops cutting. So this shape of flute would not work with the swept back wing grind that David Ellsworth uses. And these names I'm mentioning, they all have their own websites. You can go on their websites and get more information about these people. Then the next set of tools here, we'll call them parting tools. They're primarily used for, once you get your piece done, to part it off and remove it from the lathe, you actually make a plunge cut directly in and make the separation to remove the stalk from the lathe. So these are the primary parting tools. This is it's called a diamond shape, where it's fat. You can see on the side here, it's got the higher area here, and it's the thickest part is right there at the cutting edge. So that theoretically, what that does is gives you a good clearance when you're cutting in. It doesn't bind up on the sides of the cut, because this is the cutting edge is the widest point. Where this one here is just a straight piece just a flat piece of steel cut to a point. And on this, when you're parting off on this one, you make a cut, and then you come over about a half again, so you make your cut wider than what the tool is, so it doesn't bind up inside the cut. And then this is another thin parting tool that it's got a thicker area right down here at the bottom, so down here where the cutting edge is thicker than what it is up here on the top. So the purpose of that is so it doesn't bind up inside the cut. But those are parting tools. With that, I think that covers. The one last parting type tool is a bedan. And it's sort of a cross between a scraper and a parting tool. It's primarily what I use it for is to make in the tenon when I want to mount the piece in the chuck. But it's the cross section on it is sort of trapezoidal, so the widest part is up here at the cutting surface is the widest, and then it tapers down to where it's thinner, so it doesn't bind in the cut. And it's I think it's probably about 45 degrees. Okay. We mentioned, spindle gouges and bowl gouges. The spindle gouge has a shallower flute. The bowl gouge has a deeper flute. Plus, the bowl gouge is typically made of a much heavier duty steel. Spindle gouges are primarily used for spindle work where the grain is running with the bed of the lathe. So you're cutting with the grain. You're not hitting end grain fibers. You're slicing down. You're slicing downhill across the fibers, or you're planing the fibers across like that. Whereas faceplate turning or bowl turning, here's a bowl blank that Rob has started, and you can see the grain is going through the wood like this. So this came out of the tree. Here's the tree growing here where the pith is running like that. Well, the bowl would have came out of the tree like that, where the pith would have been over here somewhere, and the grain is running through the bowl that direction. So when I'm cutting that, here I've got end grain, here I've got side grain, end grain, and side grain. So you need a bit heavier steel for cutting that environment, because you need the durability to be able to cutting across the end grain fiber, just like with a chisel or a hand plane. If you're trying to plane the end of a board, you're cutting across the end grain fibers, and it's much harder than what it is to plane the surface or the edge of the board. So you just need a heavier duty tool to cut those end grain fibers. And then I mentioned that the bowl gouge, the bevel on the bowl gouge is typically 60 degrees or greater. And what that allows you to do is to be able to get down in here and clean, doing that bottom of a bowl with the spindle gouge, you wouldn't be able to get in there and ride that bevel. You get down about there, and you wouldn't be able to ride the bevel because the angle of the nose just doesn't permit you to stay in that bevel and get down across the bottom of the bowl. Or with the bowl gouge, you can come down and cut down through the bottom of it and be able to maintain bevel contact. And the reason the bevel contact, it allows you to control the cutting edge, where if you just have the cutting edge in there with no support, you don't have any control of the tool. You have to have the bevel in contact with the wood in order to be able to control the cutting edge. Oh, thank you.